Hi, hello. Welcome to our session for today, and I'm Rodson Limhap, your tech sharing presenter for uh, for today. Okay. Hi, and good afternoon. So first, on this tech sharing, we can able to you will learn about the following: the Docker or container technology and concept, then technical concept of Amazon ECS. So and what is all about ECS, then the use cases for using Amazon ECS, then requirements to implement Amazon ECS in the real world scenarios, and of course the demo and the later part of this session. Then first I will show you about traditional architecture in building and creating applications. On this picture is a setup wherein the components are being silo and run in one server or hypervisor in a virtualized environment. Application are built as a single tightly coupled unit where all the components are deployed all together. So in case here in our example, um, we see different components are being packaged together. In case of failure of this component, it will potentially impact the entire application or system. And the other challenge for this setup and architecture is the scaling in and scaling out, and how to expand them, and also it's difficult to maintain, and somehow it's a challenge to how to troubleshoot them as well. Okay, so again, as we compare this to microservices architecture, as you can see, applications are being broken into smaller independent services and communicate via API and can deploy individual component. So as we can see here, we have three services: ordering, reporting, and marketing service. Each service can scale, develop, and in case of failure, it will not affect the entire application. So in order to achieve this setup, the containerized or containerization technology comes in. So what is a container or image? So this is a lightweight standalone package wherein all the requirements, all the necessary code, runtime, tools and libraries, and other dependencies are being packaged into one. As you can see here in the picture, on the left side there's code, runtime, dependencies, and it will package into one container. So think of it as a mini virtual machine, but more efficient. Then for the benefits, so since this is a portable runtime application, it can deploy easily, and the package dependencies in a single immutable artifact. So immutable means unchanging and incapable of changing over time. So the key notes is consistency of this package. Okay, and of course ability to run different application version. So that's the keynote as well, the versioning of images. and faster to deploy, since this is lightweight, it's very fast, and entails efficient, wherein better utilization and use of our resources. Okay, so to recap, we learn about microservices architecture and Docker technology. In this concept, those technologies are being used inside the Amazon Elastic Container Service. Okay. Also, yeah, why we need Amazon ECS and what it is. So this is a fully managed container orchestration service. Next, you will able to learn the technical concept of Amazon ECS. So first, the cluster is a logical group of tasks or service used to isolate applications, and we have Fargate. We call it Fargate. The cluster's infrastructure resources are managed automatically. ECS serves as a foundation for running containerized workload, organizing, and managing tasks and services within defined environment. Okay, that's the first one, the cluster. Then the second is container, which is we discussed earlier. Application must run on container, which package all the necessary code, which we mentioned earlier. Those code, runtime, tools, and other dependencies. This container are built from read-only templates called images. So ECR, the Elastic Container Registry, is also a secured store, manage, retrieve container images used for deploying on our ECS. Okay, as you learned earlier, the container technology. Okay, then the third component of Amazon ECS is task definition. So this is the blueprint that specify how containers should run, including image, CPU, memory, and network settings. Okay, then the fourth, the task. So what is task? ECS task, the goal of this task is to run those task definition that we defined earlier, that launches one or more container as a unit. Okay, so that's the fourth. And the fifth component is the service, ECS service. This ensures specified number of tasks remain running by monitoring the health check of each task and automatically replace any that stop or fail. So this is the picture of the technologies behind this and the components. So as we discussed, started with the Docker image, then it will pass to registry. So ECS registry is the one who manage all the version images or container that we created, and this then the third is the task definition, where all the blueprint of all the requirement that we need, that includes image, the Docker, the CPU, memory, and the networking settings. And of course, tasks are these tasks are the one who will run those task definition, and of course the ECS service who keeps the set number of tasks running automatically. So if there's a task that has been failed, and so the goal of this service, you will replace let's say task 1 ECS service will trigger or notify that you will need to replace task 1. Okay, so let's jump into the benefits of Amazon ECS. So the key benefits are fully managed control plane. So since this is a fully managed service, no infrastructure management, AWS handle the cluster provisioning. So and we have the Fargate serverless. So this Fargate using Fargate compute engine, so you don't need to manage any container host. Additionally, with Fargate, each container task run in on dedicated virtual machine, which provides enhanced isolation and security by design. So of course, the third is native integration. So deep integration with other services like Elastic Load Balance, CloudWatch, and ECR. So since they are deep is the native integration, so we can able to scale and have high performance and easily scale containers with task definition, and by default is secured by VPC. Okay, so let's move to the different charges model for Amazon ECS. So we have two types of charges in ECS. Okay, the first one is using EC2 launch type model, wherein EC2 instance will run those container. Okay, and the other is Amazon Fargate. Is a serverless engine. It's a compute engine where AWS run and manage the infrastructure. The to both of them is a pay as you go model. So all the computation and the billing are calculated based on the virtual CPU, memory, OS, architecture, and storage that we used. Okay, so both of them are using pay as you go model. Okay, so for the next slide, we for the use cases. So first, batch processing and scale wave application. Let's say you have scheduled or periodically run a batch, okay, plan and run batch computing workload. So you don't need to provision infrastructure or compute the environment in order to run this environment for the infrastructure is long running. So by using batch processing, we can run a specific time based on the schedule. Okay, and of course the scale wave application, we can able to use the multiple availability zone with performance, high performance, scale, and reliability, and we can use high availability of our web application. Then the third, deployed hybrid environment, on-prem or in cloud-based environment. Okay, so for the recap, okay, learn about technical component of Amazon ECS. Okay, then for the knowledge check, so I hope you can able to answer this. Which of the following can be public or private storage for Docker image? So I'll give you a few seconds to think about it. Okay, 1 2 3. So if your answer is registry, that's correct. Okay, and for the second question, in Amazon ECS, what is the name of the blueprint that defines how the container should run, including image, CPU, memory settings? Okay, I'll give you 3 seconds to think about your answer. Okay, 1 2 3. And if your answer is task definition, you're correct. Okay, so let's proceed for the demo.
Okay, for demo on Amazon ECS, let's start on create image or container image, then push them to ECR, to the registry, and we can do that. And let's open our browser. So here we can on the search bar we can type ECR, Elastic Container Registry. And then let's create the okay ECS Cluster application 1. Okay, then can create now. Okay, so it's successfully created ECS cluster. Let's copy the URL for this. Okay, application 1. So we don't have yet the image. Then let's open the Cloud Shell here at the most top. It's like CLI and terminal. Okay, here in the Cloud Shell user directory, and I already uploaded the required code. Okay, and we can see here the other option that we can use. It's on this case I uploaded. So these are the code for our example in our demo. And so you can see the Docker file. Okay, so this Docker file will instruct on how to package our container. So in the first layer, it instruction and what bin middleware that needs to be installed or available. Say using Apache HTTPD, Alpine. The second layer, you remove the existing code and the HT docs. And here on the third layer, you copy sample code of HTTP script. Then lastly, it will expose and use the port 8. Okay. Then now you can use the so here next we can check first images. So data understood our AWS paste. Okay, then follow version 1.0. So this one share use with the current is now 18 inch. Then in case of this, let's check again the available images. Okay, one image. Push this registry. Okay, this is registry. Next. Okay, so it will appear when you create an image here. Start images. Okay. So yeah, it's successful. But in case you will encounter login problem, uh, you can use AWS ECS get login. Okay, like this, like this. Yeah, you will specify your account number. Okay, but for the meantime, it's already successful. Let's refresh it. Okay, so we are able to see the newly created image. Then URL, we can copy this, save it to your pad, or you can take notes. Then next, we will proceed to the creation of our cluster ECS right here in the search bar. Then let's run the website. Okay, so yeah, let's go back to our slide. So in our what we did, we build the image, then log in, then send the image to CR, then push it to our repository. Then now we are going to proceed creating a cluster. Okay, let's switch to the browser again. Then we can name our cluster as ECS application. Okay, then using infrastructure, using the charging that we how to charge our infrastructure and the provision of our compute using Fargate is a serverless fully managed by AWS, the provisioning of compute. Okay, then for monitoring, select container insight. Then that's it. Can proceed. Now, after this, we will proceed creating a task definition. Okay, so here it's already complete. Okay, then here the menu at the left side, task definition. Earlier I created this, but to demo the new ECS demo, demo. Okay, task definition, task definition. Okay, and then CPU size and memory. Okay, based on your requirement. Then the OS infrastructure. Then the role. You have to select the given role to execute this creation. Okay, for the image, say ECS image. Okay, then we will identify and provide the URL of the image that we copy earlier in the ECR, then the port that we are using, and also specified in our um, Docker. We expose this in our Docker image. Okay, then what else? We can use the default config. Okay, then proceed creating this task definition. Okay, okay, so successful task definition. Then let's proceed to creating task. Okay, on the cluster menu. This one is the overview. Then the tab, we have service, task, and infrastructure tab, metrics, schedule. So we will use this task. We create one. Then created a while ago. ECS demo. These are tasks, number of tasks we will run. Then networking, we will minimize uh, to subnet. Okay. Then existing, we use this security group. Okay. Then yeah, that's it. You can create now. Now we are done with the task. We'll go to the cluster. Then select this task currently functioning. Then select now task task. Again select task definition. Then this one is the service. Okay, service. Then this one deployment option default. Then this one is default. And networking, we will select a few subnet. You can select 3 for the purpose of this demo. Then we will select uh, this security group, which is if we can see this security group is this the assigned port is port 80. You can see here. Okay, so here is assigned. So here we're using port 80. Okay. So consent. Then let's go back to the creation of service. This one is default. Service discovery default. This one looking for creation of load balance. Then VPC and application load balance. So application load balance will distribute the load of the workload of application and application load balance. We also discuss previous tech sharing. So let's say the name, the application load balance. Okay, then the one we are using for ET target group ECS target group. Okay, so the rest we can set as default. Okay, so we are almost done. Okay, okay, balance. So application balance. Okay. So let's click now. So this one will take 3 to 5 minutes. So for the meantime, I'll pause the video. Okay, so let's wait for it.
Alright, so yeah, it's already done and successfully deployed. Alright, then let's check the DNS. Okay, so here, yeah, it's already working fine. Okay, so this very simple math application online. Okay, so yeah, it's working now. Yeah, and that's it. That's our session for today. Okay, tech sharing. Then just to recap, let's go back to our slide. So we learn about ECS creation. Okay, let's switch back to our slide. Where's this slide? So yeah, again, thank you very much for your time. I really appreciate your listening, and hope you're able to learn about Amazon ECS. And until then, again, I'm Rodson, your tech sharing presenter. Thank you and bye bye. God bless.